think we can do here? Oh, Brian's here. Maybe Brian can give me one. I thought Brian was here. Maybe he's not.
He is.
Oh, he is. Okay. So I think mine works, Brian. For the string one works for sure. But I'm curious if you have a big nasty array you can come up with to test this one. And then we can just throw it into my test.
I can give you a nasty array.
All right, let's get one.
All right, so nasty array equals.
I like it. Nasty array.
Square brackets. A comma 1.
A comma 1?
Yep, comma, square brackets.
Comma, square brackets.
And then 5, comma 3.
Okay.
Comma, square brackets.
Square brackets, square brackets. Square brackets.
And then 2.
All right.
And then go out 2 square brackets.
1, 2.
Comma.
All right.
Square brackets.
All right.
And then 9.
All right.
Comma 1. Okay, that should be ugly enough.
Nasty array. Here we go. Let's just change this one. Wait, why did I not just Nancy?
Might want to stick some quotes around A in the nasty array.
Let's see what happens regardless. See if we just break the thing. All right, so it didn't like A. All right. So let's.
Yeah, that's a string.
All right, so we got.
You might want to remove your. Yeah, you might want to remove your pride. Might take a minute.
Oh, yeah, I got a failure. Oh no. Might not have worked. I'm sad about that. Oh,
well, you didn't.
I
do
didn't
an
change my
expected.
Yep, that'll be why.
But flatten only flattens one set of array, right? Well, it only flattens the first layer.
I think flatten can flatten the whole thing, but maybe not. I don't know.
Talk about the actual flatten method.
Yeah, the actual flatten method, isn't it like one nested at a time?
It flattens everything, yeah. Sorry, Gary.
Okay. Cool. Nice job, man. Works.
Can flatten even more. And so I'm going to change this test back just to the regular array.
Y'all are way smarter than I am. I did not use enumerables.
So actually, this is going to be faster. So on that. Let's see that. That's the expectation. Nasty array. Doubly sure here that it did pass. Boosh. Anybody else got one?
I got it, but I only got it for 2 arrays.
So let's go ahead and do this. I want you all to do some code sharing next. I think, well, let's do this to poll before I make any assumptions here. Can I get everyone to open up the participants panel? And can I get a gray go slower button if you want to look, if you, so what I want you all to do is I want you to review either, share your code for either your implementation of dot flatten or your implementation for reverse. So whichever one you think would be more helpful to review and code share, that's the group that I want you to be in. So can I get the gray go slower button if you want to review? Oh man, I'm trying to do like neutral, but slower and faster is not what I want. Let's just do yes. Can I get a green yes if you would like to review the reverse method in a small group? And let's do the no for the flatten method. So green, yes for reverse, red for flatten. Sean, I don't think we're gonna have time to do both. I think I'm gonna put you in groups for about 15 minutes and you can certainly look at the other one as well, but I think you'll have to have like one entry point. Gotcha. Okay, well, it seems like if there's some people asking to do both of them, let's go ahead and do this. Let's go ahead and review both of them, and I'll give you all a little bit longer to review them because it looks like I got some of those comments. So yeah, that's fine with me. I will put you into breakout rooms of about 3 people each. And yeah, I want you to share your code and we'll do both for dot reverse and dot flatten. We'll do this for about 20 minutes. And then when we come back, I want to talk about this together. And I think that's about it. Does anyone have any questions before I let you go? Okay, your rooms are open.
I'm not sure if I don't think I can pop around as even like the co-host.
Yeah.
I'm just thinking about that.
Yeah. I think the only thing I could do is to manually put you in there. That's probably the best we can do. And then if you want to like move around, you can Slack me and I can just manually move you. I don't know any easier way to do it.
Cool. Yeah, I think that's fine.
Cool. All right. Well, I've got you in a room right now, so just shoot me a message when you're ready to move.
Sounds good.
Yeah, so I kind of missed out on that part, but
yeah,
I didn't end up doing flatten mostly because I got reverse done, and I just got a little obsessed with it because I'm just like, that's too many lines of code. We can make it smaller. So I just kept on working on it, and I got to a point where I liked it, or I could probably still make it smaller, but I'm like, yeah, it's not like code written everywhere.
Using the size of the string versus like checking for when it's empty.
Yeah.
There.
Nice.
This is my reverse.
Cool.
And I even wrote some mini tests just to feel nostalgic.
I saw that. I was like, man, I did none of that.
6 and you're 8 or something like that.
Well, this whole thing's nested, right? Oh yeah. So so I'll put.
So
this.
like put like
Yeah, that'd be good. Just put a
Yeah.
rex on 6.
Yeah, if I put that around 6, we'll redo it. I did this earlier. I'm fairly certain it works. If not, oops. I guess I'll take out the pry just so I can get a quick answer. So yeah. So we can put the pry back.
So it looks like it gets rid of all nesting immediately.
Yes.
It doesn't get rid
It
of.
just
is my
converts
correct
the
in it doesn't
entire
get rid of
thing into
one
a
layer?
string. And then once it's a string, then I just have to go back up one level, turn it back into a single array, which is what the split does.
Okay, so gotcha. But I think flatten generally removes one layer of arrays,
No,
whereas
it
this would
actually- it
remove all
removes
the layers
everything.
of arrays.
It removes all the layers.
All the
Okay.
layers. Yeah.
That's cool. Nice.
And then for reverse, I just basically same logic. I just split the string, so made it into an array so I could iterate through it. And then I just unshifted all the letters into my empty array here. And then I just call my empty array and join it so it becomes a string.
Cool.
Gary, in your pry session, sorry to jump in here. Could you all do, what is nested array?
Where?
Pry session.
Here? It's this.
Could you type that nested array into the pry session?
I feel like it shouldn't be working, which is fine. Shit.
Yeah, and then nested array dot join comma. What does that give you? Nice. Yeah, so this is a very, I would say this is a very creative solution. I wouldn't have thought to like turn it into an array and then like string split it. One thing to consider here is what is the join method doing? I think like if I were your interviewer, this might be what I would say. Okay, like this is a very creative solution. It looks like what the join is doing right there is it's essentially like removing all of the nesting for you. So it kind of looks like by calling .join, you don't have to deal with like any of the nested array. So I think what's going on is that .join is still doing some of the functionality of .flatten, which is the process of like going through all the nested arrays and pulling the elements out of it into a single array. So my question would be like, in terms of number of operations, you're probably doing more work than you need to, because you're making Ruby essentially like go through the nested array and undo all of it with .join, and then you're making it go through the string a second time to then split it. So I'd say like this solution is creative, but it's maybe not efficient.
Got it. So like this would be sort of like, I think I was asking you back in our project check-in randomly about like the runtime efficiency and stuff like that. Like this would fail that check essentially is kind of what you're saying.
Right, yeah, in terms of runtime, like runtime is all about the number of operations. Well, our runtime with flatten here is, it seems like .join is doing the .flatten for us, but then we've added on additional runtime for iterate over every character and split it on the comma. So if there was a way that we could do, both of these seem like they are dependent when we're talking about runtime. Both of these methods seem like they're dependent on the size of the input. So the bigger the array, the more work join will have to do to unnest it. And then the bigger the array, the bigger the string, the more work we're going to have to do to unsplit it.
That makes sense. Is there a way like, or is it just you have to kind of do it manually /no? Is there a way to like check the runtime of a given solution so that like I can just kind of get a sense for this kind of stuff?
Yeah, there's a Ruby library called Benchmark, I think it is.
Okay.
I think that's what it is. But it's essentially like it'll time how long something would take. So you could time this flatten method versus another flatten method and time it with different inputs and see which one's faster.
Yeah, now that you're saying all this, I see why. Like, yeah, if I couldn't use join and split, then obviously like I would have to just iterate through all of the arrays. That would take me a little more time to think through how to do that, but like I'm pretty confident I could do it that way. This just like stuck out at me and was like, wow, this is super easy.
Yeah. Well, I'm sure some of the other people in the group did it with iteration. Am I right?
Yeah.
Yeah.
I totally misunderstood the assignment and didn't even do it. So I got to work on it myself.
You're doing
Zach
great.
also misunderstood it. He thought you were just like playing around with the two methods, not creating them. That was his thing. I met with him right before class.
Anyways.
Anyway.
Yeah.
So I guess it would be, Brian, it would be the same issue. Like my string, my reverse method is kind of also cheating a little bit with the split and join, I assume. Or I guess here not as much because we aren't trying to recreate flatten. We're just trying to recreate reverse. So it's not as much. These actually aren't cheating in this one.
Yeah, I think what I'm trying to push you towards is like, when you call these Ruby methods, yes, you can just like call them and they just work, but you need to think about like, what does that method have to do its thing underneath the hood? Well, if for dot split, the only way that like a string could actually just be split on a character is if we go through every character. So when we talk about runtime, that's a linear runtime. For every input that I get, for every character in my string, I have to do something for each one of those characters. So a lot of times your runtime, when you're thinking about that, is all about just like thinking through the for each. What do I need to do for each thing? So in this case, like dot split adds a for each, string array dot each adds a for each on top of it, and then dot join does another for each. I need to take each one of these characters and join them back together. So you're essentially doing this with 3 loops. What's a way you could do it with 1 loop? That's the question I'm asking. And with that, I think I will leave you all to it.
Yeah, thank you for that. Appreciate it.
Garrett, let me show you my crazy that was reverse.
Are you all doing all right?
Yeah. Yep. I think so. We kind of went over some solutions that we came up with. And yeah, just been kind of talking since then. So
cool.
I don't know if anyone had any specific questions.
I don't have any.
Cool. All right. Well, I will leave you all to it then.
Cool. Thanks.
Figuring out problems with limited access. Like you haven't done that much Ruby lately, and like I get that the projects can be draining because they're constantly pushing you to do new things. So it's nice to get like a check back in on things that like feel probably better than constant novelty of the projects.
I do think that was precisely it for me, at least, because I was able to like navigate and have a good plan and understanding of where I'm going.
So I would rather not share that okay, this is a really nice change of behavior. So yeah.
Yeah, you were probably done in 5 minutes, huh?
I was, yeah. I was like, is this
why do we have so much time? Yeah. Yeah.
Just gotta read the directions a little better, I guess.
Yeah, I'm a little frazzled from last night, maybe.
Yeah. Huh.
So, but yeah,
always about the habit thing. Hey, Brian. None of us are currently sharing, I know.
Pretty much went through it.
Yeah, y'all got it.
I learned a lot about that I should check if it's an array. I didn't do that and mine failed, but yeah. So that's cool.
Do y'all have any questions or anything I can help with?
No, not off the top of my head.
All right.
Yeah, same.
I'll leave you all to it then.
Okay.
We need to do it again and again, do it this way. And so I was trying to figure out how to read in argv and nested arrays. And that kept crashing every time. I'm like, what? So do I read it in as a string and then change the string into an array? But what? And then like when I was doing that, then I was like nesting strings that held arrays inside arrays. And I'm like, I'm getting stuck up on the semantics here, like of like reading in an argv. That wasn't even like really the challenge, but I was thinking, like our enigma, like we read in the variable or like the string. And so it worked fine for reverse, but I couldn't figure it out in an argv, in an argv way. So like, do you have any helper methods for my flatten? It's just in one.
Just in one. Yeah. Brian, if you have any advice here. So this was mine. I got it to work with each enumerables, but I tried to change it to map. And I couldn't figure out exactly how to get it to work with map.
Gotcha. Can you comment out the okay, well let's answer that first question. If you comment out the first one that works with .each, that's what you wanted. Second one's the one you're trying to get to work. So you want to map, so you take your nested array and you want to map it to, okay, so I think probably what you need yeah, so when the inner map, when you just have array.map, do element and then element, essentially you're mapping you're mapping the array to itself. So that line won't really do much. I don't know if there is a way to do this with map, because you're not really like those subarrays, you're not really, map will transform something for you. So it'll take your subarray and it will it'll map each element to a new value, but that's not what you really want. You don't want it to return a new array for you. You want the elements in the array to become part of the outer array. Does that make sense?
Yeah. Yeah.
So essentially for every map you have, the return value of that map will be a new array. Or will be a new array. So you can't use .map here because then you would still end up with the same arrays. So I think what you want instead is, yeah, I don't think there is a way to do this with map is what I'm saying.
Okay.
Yeah.
Cool.
If you comment out this version with map, and then you go back to your other version, it looks like you ran this from the command line. Can you do that? You ran flatten.rb? Yeah. If you, for that first nested array, can you put in an element in the first position that is just a number? Yeah. So I see that all of your elements in that array are nested arrays, but what happens if we just have one number outside of an array? See, it doesn't quite happen. So I think you need some additional logic in your flatten method to handle the case when this this element in this block variable, when you loop over this, what if it's not an array? So you could have some if logic to say, like, if it's an array, do this, but if it's just a number, you don't need to do this inner array like this.
Okay. Is this something?
Yep, that'll work. And then pass it the class that you're expecting. Exactly. So if it's an array, go through each element and pull it out. But if it's not, what are you doing?
You just want to shovel it in.
Exactly. So if it's just a number, you can just shovel it in. Cool. Let's run that.
Awesome.
So that's one case. And then the other case is because you have two eaches here, what that's kind of indicating to me is that you're working with this at a 2-layer deep nesting. What happens if we add a third layer? So for instance, what happens if in this first array here, we wrap one of those numbers in another array? Yeah, so if we put 2 and 3 into another array, what happens? So it looks like for this first one, we didn't handle that. We didn't handle that array.
Mm-hmm.
So what you need here is you need some additional logic to say, rather than just check if it's an array at this level, we need to like infinitely keep looping down, keep digging down into these arrays until we find a not array. So you need to account for the possibility that when you find an array, that array now contains subarrays. And then when you look at those subarrays contain subarrays of subarrays of subarrays. Like you need to be able to handle infinite levels of nesting.
Okay.
So we've got our time is up for our room. So I'll give you all a couple minutes to just think about that and talk about like how could you get around this.
Cool. Thanks, Brian.
You're welcome.
0
Oh,
goes,
okay.
yeah, so it gets the first thing in the args array, which might be nil or it might be a number. If it's not a number, then funky stuff happens. But there's probably like an error or something. But if it if flatten, so if it is not 0 and it is a number, then it checks whether it checks again, it does exactly that, except when it comes to calling its recursion, it calls kind of flat and then arg0 minus 1. So that means that, say, like when we put this one in, which would be the second one over here, this is the original, this is the first, this is the second here. So the second one should only flatten once, because 1 minus 0 is 0, and then when it goes back to the beginning, it hits this else if, where arg0 is 0, and then it just returns the thing that it got in here, which goes back through this one out to the top.
Nice.
Yeah. Aiden, I just joined y'all a little bit late here. Is your flatten method, do you need to pass the like level of nesting to this method? Is that how it works?
No, you can, but you don't have to. Like if we pry in here, right?
Oh, gotcha.
And we
Okay.
copy, oopsies, copy this line here. Then we can do like just that, and it will completely flatten it. But if we give it an argument like 1, it'll only flatten one level of it.
Nice job. That's
Yeah.
very cool.
Yes, I just remade the complete flatten functionality. Is what happened. So
great job.
Yes,
I'm going to close out these rooms next.
Cool.
Hello again.
It looks like I'm muted. Now I'm not muted. Welcome back. What I'd like to do is I'd like to go over some of this as a group. Yeah. So what do I want to do? I want to open up a Ruby file here, and oh yeah, it looks like that's what I did last time here. So I want to start by talking about this this reverse method, and the first thing that I want to talk about is a couple. I saw a couple people like reusing some Ruby methods in order to do reverse, and so I kind of want to like model what that might look like. So if I have a method here, def my reverse, and I pass it some sort of like string. So I'll just call this argument string here. So I want to be able to call my reverse. So puts my reverse and then pass it an argument. So if I pass it hello, I would like to see the string hello reversed printed out. So if I run this now, we're just going to get nil printed out because our method is returning nil. So I could do something like this. I could say, well, I want to take this whole string and I first want to split it. So let's just say dot split. And if I pass it an empty argument here, then it's going to split it's going to return to me an array. So I'll call it characters. It's going to return to me an array of every character. So then what I could do is I could say, let's create a output, something like this. So I've got an empty array, and then let's loop over each one of these characters. And then for each one of those characters, I want to put it at the end of this array. So I could say something like output dot, I think the method would be unshift. Let's just see what it does.
Yes, that is correct.
Output dot unshift car. And let's, rather than puts, let's do P here. Oh, and remember, when you do an each will return the original array. So I don't want to actually I don't want to return this cars method, this cars array. I want to return my output here. So that's going to give me a it's going to give me a string, or sorry, it's going to give me an array of all my characters. So then maybe rather than doing that, what I actually want to do is dot join here. And that will print out my string of hello backwards. So this is one way that I could consider doing this. One thing that I want you all to think about in terms of these Ruby challenges, and this is something that interviewers will most likely push you towards, think about the efficiency of this method, or think about it in terms of the number of operations that you need to do. And what I mean by that is think about all of these methods that we call. What do those methods have to do under the hood? So a lot of times it looks like methods like dot split and dot unshift and dot join, like we just call them and they just work. But Ruby has underlying libraries that define how these things work. So if I think about how dot split works, how we need to split every one of these characters, well, what we need to do to split something is we would need to iterate over every single character in this string and put it into an array. So that's one iteration there. Then I have another one here where I need to iterate over this entire characters array. And then I have a third one here. Well, how would Ruby know how to join a string? Well, it would, or sorry, know how to join an array. Well, we would need to loop over every element in our array and put it back into a new string. So between dot split, dot each, and dot join, that's 3 iterations over this string that I need to do. So when we talk about efficiency, or we talk about number of operations, what we're really talking about is think about it in terms of the size of your input. If I need to do something for every element in my input, for instance, if I need to do something for every character, or if my input is an array, if I need to do something for every element in an array, that for every or for each, that is the basis of thinking about efficiency in terms of computer science. So This gets a little bit more complicated. This gets into like runtime. This gets into big O, big O, big theta, that kind of notation. For now, we don't need to go that deep into it. For now, I just want you all to think about what's the number of iterations that I need to do. Does the size of my input affect how long this would take? What questions do you all have about that? Besides what's maybe a more efficient way to do it? Hope.
Well, for starters, you can call string.cars and it will split the string for you.
Right. Yeah, so rather than do .split here, I could do .cars. Oops. And let's just test it. Yeah, that does work. So that does work, but kind of the same point here. If I call .cars, what needs to happen under the hood? Well, the only way we could get all the characters out of the string is if we look at every single character and put it into an array. So different method call, but it's still doing the same thing under the hood. Let's also do some edge cases here. So like, let's just look at an empty string. Let's look at spaces. We'll add in some edge cases here. And we can see that it'll work with other inputs as well. Okay, so I've identified there are multiple iterations going on here. I'm looping through. So this is all to say, like, if you did it this way or you use some of these Ruby methods, it's not that you did it wrong. It's that there is the next step is to think about efficiency. So I can get it to work, number one, then can I think of a more efficient way to do it? So if I was actually developing this method, I would probably write something like this first, just to see like how this process would work. And now I want to look at my methods and see if I can identify ways to improve this efficiency. So rather than looping over my string to get all my characters, looping over all my characters to put them in this array, and then looping over this array to join it back together, I want to see if I can do this all in one pass. If I can just do one iteration and have it still work. So let's see what that might look like. I can do def my reverse. And so then I could do something like this. I could say string.length.times do. And this is going to give me some number, which I'll call an index, something like that. So this string.length method here, this is not something that Ruby needs to iterate over the string to get. .length is something that Ruby will know how to it doesn't calculate it, it stores it. So this doesn't add any complexity here. And so then what I can do is I can, let's create a new string here. So I'll say new string equals, and this will just be an empty string. And then what I can do is, so this index will represent to me, what do I want to do here? I think what I really want to do is I want to go like backwards over this array. So I could do, let's do this. Let's do string index. And let's actually, I'm going to put a pry in here. So I'm kind of modeling for you like how I would actually go about doing this. The first thing I want to see is like, can I just loop backwards over this string? So I've got a pry inside this times loop. And let's take a look at index. So index is going to be 0. Let's just exit a couple times and see what index is. So index goes from 0 to 1. And then I imagine it'll just keep going. Oops, I think I exited too many times. So it's at 3. If I exit again, it'll go to 4. If I exit again, it'll go to 0. Gotcha. Okay. So it went, because I had a string length of 5, it went 0, 1, 2, 3, 4, 5. So that all looked good. What's index here? Index is 1. Cool. So if I do string index here, I just want to see if this works. This will give me a character. And this, at this point, I think I'm looking at this E in my third hello. Sorry, in my third input. So if I rerun this and look at string index, so I get H, let's exit again, E, exit again. So I'm not quite looping over backwards. I haven't quite done what I wanted to do there. So let's try and achieve that now. It seems like what I'm going through is I'm looking at each character sequentially. So I think what I actually want to do is I want to do string.length.times do, and rather than keeping track of this variable here, I think I'm gonna have to manually keep track of an index. So I'm gonna say index equals, let's say string.length. So this will be the length of my string. And I think rather than a times loop, what I want to do is a while loop. So I'll say while index is greater than 0. Let's say while it's greater than or equal to 0. And then inside here, let's just try to do a minus equals 1. So I want my string to start at the highest index and then go down through 0. So, oh, and I don't have a pry anymore. Let's just put require pry at the top so we don't have to keep doing this. Cool. So check my first index. It looks like it starts at 5. Let's look at what string index is. Because I have 5 characters in this string, I'm imagining that this index is 1 character too high. So I think I actually need to start this off at string.length minus 1. So now let's see what it does with that. Okay, so the first time through, my index is 4, exit again. The second time through, it's 3, that looks good. Then we're gonna go to 2. Then we're gonna go to 1. And now I'm hoping that it gets to 0. Okay, it did. And if I look at my string, I'm still looking at my first case hello here. So I think that's good. I actually want to comment out these other two because now I think we're going to go back to the other string case. Oh, no. Oh, now it's at 10. Cool. Okay, I think this worked. I think so what I've confirmed is that I was able to go from my highest index, which was my 4. For a 5-letter string, my highest index should be 4. I was able to go to 4 down to 0. So that looks good. So really what I'm trying to illustrate here is not just the Ruby portion of this, but also the process of I just want to do one thing at a time. I just want to see can I iterate over all my indexes starting from the highest to the lowest? Now that I can do that, well, I think what I can do is I can grab the characters that correspond to those index. And I think what I want to do with that is I just want to add that on to my new string. And then I think once I've added those on to my new string, I think I can just return it. And I do like to do explicit returns. Cool, and it printed out that reverse string. Let's uncomment these other two examples and see if those still work as well. Cool, so it looks like my solution is passing. So my process there was to identify high-level steps of what I want to do, write it out the simplest way that I can, and then start to refactor. So I'm kind of doing red-green refactor here. Get it working, then think about how I can make it more efficient, then see if I can get it working with that. And as I'm refactoring, doing one thing at a time. And that's what my method looks like. Yeah, do you all have any questions about this implementation? All right. Let me do the flatten one as well. And I mostly want to talk about this flatten method because this is a good place for us to talk about recursion. So recursion is a concept in computer science that's used pretty often that is very hard to wrap your head around at first. I think the main point of me talking about it right now is to kind of like introduce you to the idea if you haven't heard of it before and kind of get an idea of what recursion is and how it works. So let's go ahead and jump right into it. So recursion is the process of a method calling itself. So let's define a method called, let's call it myFlatten, and it'll take in an array. It'll take in a, let's call this nested array, like this. And let's try it. Let's just put out some use cases here. So let's print myFlatten, and we'll try to flatten like a really let's try to flatten a really nasty nested array. So I'll just put in, actually, before I do that, let's just put in like a single nested array, something like this. So if flatten is working correctly, this should flatten this one layer, and it should just print out, I'll put it in a comment here, it should just print out an array of 1. So it should remove this one nested level. And we can see right now it's printing out nil. A good thing that I saw some of you doing to check this, I could print out like something like actual flatten. And I could just call flatten in here. I could call flatten on that nested array. So I could say like test array equals this thing. And I will compare my flatten method with test array dot flatten. Oops, spelled that wrong. There we go. So we can see our actual flatten gives us this array of 1, but our flatten method is returning nil. So the first thing I want to talk about in terms of recursion is what does recursion looks like? This is what it looks like. Anytime you call a method inside that same method, you're going to trigger that method being called from inside that method. So this is a recursive call. This is the only thing that you need to create recursion. A recursive method is just a method that calls itself. Now, the issue with recursion is when you have a, actually, the first thing I want to talk about, let's actually do this. Let's create another test array here. And let's just put some numbers in here. It doesn't really matter what these numbers are. It's kind of hammering on the keyboard. Let's wrap some of these in like some really nested arrays. So we'll wrap all of these in an array, and then we'll wrap maybe these 2 in an array, and then this 1 will be in its own array. So the first thing I want to talk about is like what makes a good use case for recursion. The first use case, the main way that you know you need to recurse over something is when you need to do something an unknown number of times. A lot of times that indicates this could be recursion. So if I look at this whole array, in order to flatten it, what I need to do is flatten this entire subarray. But then within that array, there's all of these elements. And if I look at just this array, well, that array needs to be flattened. And then if I look at that array, inside that array, this subarray needs to be flattened. And then if I look at that subarray, I have an even smaller subarray that needs to be flattened. So when you have identified that you can solve a problem by doing the same thing at smaller and smaller scales, that's a good sign for recursion. Well, flattening this entire array is just a matter of flattening this subarray, and flattening that subarray is just a matter of flattening all the subarrays within that subarray infinitely until you're done. So whenever you're kind of like describing a problem like this, that's a sign that you need to use recursion. The issue when you've identified you need to use recursion is that if you just call your method inside your method, well, then your method, when you call this method, it's going to call this method. So it's going to call the method again. So it's going to call the method again. So it's going to call the method again, call the method again, and you get stuck in an infinite loop.
Hey, Brian.
So, yes.
You have a issue with your myFlatten method?
Yes. This one?
Actually, the main level of it. Check in the argument.
In this one?
No, above that.
In this one.
Mm-hmm.
I'm not seeing it. Let me run it and see what happens.
You just spelled array wrong.
Oh, I spelled it wrong twice. Got it. Yeah, I'm not actually good at spelling. I just read my errors. Okay, fix that spelling. So if I just run this method as is, what I'm going to get is a stack level too deep error. This is your computer telling you that it was stuck in an infinite loop. It tried to do this thing over and over and over again until essentially my computer just ate up all the memory that I had available, and it says like, whoa, I can't do any more recursion, like I'm recursed out. So when you're doing a recursion, what you need is a base case. And a base case is, how do you know when you're done recursing? Well, my base case in this case is if nested array is a array. So if this element is an array, if I'm looking at an array, well, then I need to flatten it further. But if it's just a single element, I can stop flattening. I have already flattened it. So I need an else here. So if my nested array is an array, I need to keep flattening it. But if it's not a nested array, then I need to loop over it. I need to loop over every element. And I need to flatten all of those elements. Another thing to note here is that we need to keep track of what our output is. So I could do that with an optional argument here. I could say output equals, and I'll give it a default value of an empty array. And so whenever we flatten these nested arrays, what we need to do is we need to add that onto our output. And at any given point, I think we would also need to pass in our output. Something like, actually, I don't know if we actually need to do that. Yeah, I'm not exactly sure how that would work. Is a question mark, I think, is the way that would work. I would need to also output plus equals here, and I think I would need to return it at the end here. And I'm going to get a stack level too deep here. So this is the point where I think I'll go ahead and I will keep working through this if you are interested in my solution. If you all want to run for lunch, I do understand that it's noon. I think I've covered everything that I really wanted to talk about in this challenge review. I think the main sticking points are like, have a process for working through these things. Try to take it one step at a time. Try to like keep your eye on keep your eye on the ball. Try and like make sure that you're working on one specific thing throughout this entire process. And I also wanted to expose you to this idea of recursion a little bit. So I will keep working through this. If you all want to run, that's totally fine with me. I will post a recording of this. So if you want to just like see where I got to in the recording, that's fine as well. But that's going to be it for this morning if you're running. We are going to have a attendance thread for the afternoon. It's project work time, so keep an eye out for that. And then one other thing I do want to do before I keep working through this is I do want to drop surveys for this morning's classes. So if you all could take a minute to fill out that, I would really appreciate it. Sean, do you have a question?
Yeah, I'm just curious, since recursion deals with like the concept of like infinitely looping, the base case would always have to be like a Boolean statement, is that right?
Pretty much. You pretty much always need some sort of conditional logic to say, if you need conditional logic to say, if I've reached my base case, I need to stop recursing. But if I haven't reached my base case, then I can't stop recursing.
I guess I'm curious, is it ever the fact that your base case would be like some kind of set limit, like 100 or something like that? Because it doesn't seem like it, I could be wrong, because of that whole concept of how it might have to infinitely recurse.
Oh, so your base case could never be a number of times you've recursed. So for instance, like keep track of the number of levels that we're nesting and then stop at 100. That would be like a separate functionality if you had it. And I think actual Ruby Flatten does this, where it lets you put in an optional limit argument. And I think by default, it's just nil, like you just can infinitely loop. But if you pass it something like limit of 2, it'll only remove nesting at 2 levels. So I'd say that's not so much of a, it's kind of a base case. It's kind of like you're adding in an additional base case of keep looping until we've unnested everything, or we've gone 4 levels deep or whatever it is.
Okay, thank you, thank you.
So I think I got a little flustered with time there at the end, which definitely happens during like technical interviews. So I am really trying to model here, like come back to my process, come back to what I know. Okay, so when I'm trying to flatten this thing, I need a base case and I need to check if my element is not an array, I don't think I actually want to flatten it further. I think that was wrong here. If my element is an array, if my element is an array, okay, so I think this is where I had it wrong. I think this is where I need to do it. If my element is not an array, I think what I need to do is I just need to put it into my output. So if this nested array is actually not a nested array and rather just a single element, put it into the output array. Okay. But if it is an array, what I need to do is I need to loop through every one of those elements. And I need to flatten them because those could also be nested arrays. And when I flatten them, I need to pass my current state of my output. And that's going to return to me my output array. So I don't actually need to plus equals here. I think I just need to equals here. Let's see what that does. Oh. Okay, so my version printed out what actual flatten would print out. Let me just be a little bit more clear and say my flatten is printing out this, and actual flatten is printing out this. Yep, okay, so that looks right. Okay, so now let's do, let's try it on test array 1. So again, following my process of like small case first, let's see if that works. Let's go to this bigger case here. Yeah, there we go. Figured it out. So one thing that I don't think I did a great job of explaining of how I figured this out is because we're executing multiple method calls here, we're calling myFlatten several times. What we care about is the return value from the statement. So for each method, it's going to return the last line of code, which is my output. So if my current output is the thing that's returned to me, when I made the decision to change this from plus equals to equals because I noticed, well, it's going to return to me my like new version of my output array. So I don't need to like add this on to my current version. I actually just need to like reset it. So this method call is going to update my output. So now this is my most current version of my output. So I just save that value there. So thinking about what will my method actually return is very important. What questions do y'all have about this? And as you all think about questions, I'll kind of like write down a lot of what I talked about. So for recursion, the recursion definition is calling a method inside itself. In order to successfully recurse over something, you need three things. So the first thing that you need is you need the recursive call. This is the easiest thing. This is just the method needs to be called within the method. The second thing that you need is a base case, which is how do you know when you are done iterating? Or sorry, how you know when you're done recursing. And then the third thing that you need is you need to change the input. So you can't just call the recursive method with the same input, because if you kept calling it with the same input, it would never get to the base case and you've just recreated that infinite loop. So my changing of the input was I'm calling myFlatten here. This is my recursive call. And just to be very explicit, I'm changing the input to the recursive call. So my recursive call is right here. I'm now changing the input by passing in a different element each time. And I'm also passing in the newest version of the output. Garrett.
So I guess like in like an interview situation, because I guess we're not gonna necessarily, depending on how complex the problem is, right off the gates know for a fact like what is the most efficient solution here. So maybe like if we're in an interview situation, would you like maybe talk through all of the ideas you have in your head and then kind of like explain your logic for why you think one of them would be the most efficient and then just run with that one?
Yeah, I'll give you, I'll tell you a story here. The technical interview that I did for my first job was to write a method that would print out n number of Fibonacci numbers. So if you're familiar with the Fibonacci sequence, it's essentially like the next number in the sequence is the previous two numbers added together. It doesn't really matter what the actual sequence was, but having done like enough recursion and having my professors kind of talk about this, I thought like, oh, this screams to me something that could be done with recursion or could be done. Every problem that you could do with recursion, the opposite is to do it iteratively, or maybe the other choice is to do it iteratively, where rather than recursively calling the method, you set up some sort of like loop or whatever to say, keep doing this until some condition is met. So it'll result in the same output, but it's just using loops rather than recursive method calls. So I identified this and I asked the interviewer, who ended up being my boss, which would you prefer that I do? And he told me, I don't care, I just want you to get it done. So I think a lot of times it depends on the specific interviewer, but usually they are not looking for you to pick like recursion or iteration. Recursion, just for some people, mentally, they can think through it a lot easier. And in fact, some languages like Elixir is a newer language that doesn't even have a notion of loops. It only allows you to do things using recursion. So if you're going for an Elixir job, it might be more appropriate to use recursion than over iteration. So the point of me telling you this story is that like there's not one right answer. A lot of times, Garrett, you had the right idea. Talk through both of them with your interviewer and ask them what they think. It's always a good idea. Like what interviewers are looking for in this situation is more about like your problem solving process and how you go about solving the problem rather than your specific knowledge. So it would be a good idea to identify two solutions and ask for their opinion. And they might just say like, you decide. But I think it would still be a good look to ask. Is Tim in here by any chance? No, I think he had to run. But I think Tim would say the same thing. Any other questions about this? I think that's about it. There's probably another version of this where I don't actually have to pass this output here. If you're not really familiar with this syntax, I think I could do something like, rather than that printing out the output, I think I could just start my output as an empty array. And then yeah, so my method would always return my output, so then I could plus equal it. I think that's how I would do it. Yep, so that's how that would look. So small change. Yeah. But again, this is me thinking about what my output is going to represent and what I want to do with it. Well, I actually want to add it on to the end of this output. By the way, this like when I came back, I do want to emphasize like this is what I was doing in my head. I was saying, okay, I'm running out of time here. I need to come back to what is my process? Well, I know there's these three things I need for recursion. So let me think through them, check that I've had all of them, and that was what allowed me to solve the problem. So I do want to emphasize like it is not magic. It's not just a matter of like knowing every problem. It is a matter of, especially when it comes to technical interviews, it's a matter of keeping your process in mind and working through it intentionally. And with that, I think that's a good place to wrap up. Thank you all for your time.